Kill Ankrum, and this is Physics Lab 2. In this lab, we're going to be observing the relationship between the magnetic fields and observational distance. And we're going to do this by creating both a computational model to theoretically determine the results, and then also an observational model where we actually carry out the experiment. Some key concepts to know before getting into this lab is the Biot-Savart law, as well as the concept of distance dependence and magnetic fields. You can see the two formulas for on-axis and then off-axis when it comes to magnetic fields. And these are a slight preview of my results getting into the lab. So in this experiment, we had a system, which is the phone sensor, and then the surroundings, which is the earth and the bar magnet, and then obviously everything else going along with that. For this lab, we to orient it, we moved the phone horizontally along the x-axis, and then vertically along the horizontally along the x-axis, and then vertically along the x-axis to find the magnetometer sensor in the phone. And then doing that, we measured the distance between the magnet and the sensor for different magnitudes, different distances. And in our results, basically what we discovered is that the further the magnetometer is from the magnet, the closer, the further the magnetometer is from the magnet, the closer it is to a near zero magnetic field, and vice versa. Apologize for that typo there. And then using the y value here, the slope, and then the 14.53 for our natural log of k, we were able to computationally find k, and then with that value determine the magnetic dipole moment on axis from our observed experiment. For the theoretical, we used the the magnetic dipole moment I got from the observed experiment, and plugged it in, and then set it to measure the perpendicular on perpendicular, parallel, and then 45-degree magnetic magnitudes. And we found was that the computational magnitude and the experimental magnitude were kind of off by a good bit, and there are a couple of reasons for why this could be. Possible like rounding errors when carrying out calculations, interference with technology could have played a big part. Human error, just in general, human error in results, because nothing was like standardized. It's all using my hands or whatever. And then external electrical fields that maybe weren't taken into account for. So what if in the experiment you oriented your setup so as to compensate for the magnetic north? What if you hadn't done that and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? So we would get a lower value for the magnetic field because it's not on axis. So like some of the values would be skewed towards the Earth's magnetic north, and then because of that skew, it would also increase the difference between our theoretical and experimental values. And then what if you had two identical magnets? What if you redid the experiment, but instead of using a single magnet, you had two identical magnets stuck together end to end? How would you expect your measurements to differ? The magnetic field would be doubled due to superposition, but the direction will remain consistent.